Top. Début de la séquence finale lanceur.
He's just announced the beginning again of the synchronized sequence. We now have gone into the automated phase. The computers are performing a whole set of checks and controls now before launch, and they're managing a very impressive list of operations. And of course, this is the final phase in a sequence of events bringing us to today.
Most of the elements that make up Ariane 5 come by ship from Europe. They then travel by road to the space base, where they're assembled. Transported to this building for positioning on either side of the main stage. Then the upper stage is integrated onto the lower stage, and at this point Ariane is moved to the final assembly building. The satellites arrived by plane. Thor7 came on February 20th and SICRAL2 on March 4th. Dedicated to satellite operations. Preparation includes weighing and testing by special teams in clean rooms. All satellite systems are checked. Everything from electric cables to solar panels. Tests completed, the satellites are then filled with the fuel they will need for their lives in space. These white suits worn by the crews are quite heavy. They weigh 17 kilos. Meanwhile, Ariane space and customer teams meet on a daily basis to review campaign activities. In all, a campaign takes 6 weeks to ready both launcher and satellites. When filled, the satellites in their turn move to the final assembly building. Here they are mated atop the launcher. SICRAL2 was put in place first in the lower position, then Thor7 the start of her mission.
Well, that was yesterday. Here's today. Here we are back in mission control. And as you heard earlier, I mentioned that the base is a pretty huge place. It covers nearly half the size of Rome, and there are so many different facilities here, mainly the launch satellite facilities, a whole range of other buildings. And we call it the range. This includes actually the power range stations, or the ground stations, which are dotted along the flight path, and they track the launch vehicle as it flies over. You can imagine the logistics involved in everybody communicating with each other, and that's why all the information is sent here to mission control, and everybody listens to the range operations manager. So the other control room, which is important here, is the launch control center. This is about 3 kilometers from the pad. It's often known as the bunker. Various different teams working here. One's responsible for ground operations, led by the launch site operations manager, and the quality team then make sure that all the regulations and rules are adhered to. Another team ensures the flight readiness of the vehicle, led by the area production manager, there he is, and I oversee the operations from the assembly of the launch vehicle to the moment of launch. And we also have a safeguarding team who make sure that all the operations are carried out according to very strict rules, guaranteeing the utmost safety here at the base. About a month ago, the computers on launch pad 3 sent the liftoff time to the computers on Ariane. We were talking earlier about the umbilical tower. You can see, you may not see them very well from this angle, but if you go up to the top of the vehicle, you can see 2 arms. We'll get another angle on this in just a second. And they are feeding cryogenic propellants into the upper stage of the launch vehicle. You can see them now, 3/4 of the way up on the right-hand side, 2 great big, we call them cryogenic arms, plump -3 degrees for the hydrogen and -150 for the oxygen. We have to keep them that cold in order to maintain them as liquids. And they do tend to evaporate, so we keep those oils there right until 7 seconds before launch, and we disconnect them. Just before launch, you'll see them dropping away. The folk here going outside now to view the launch from the viewing station. You'll see a 7-second delay between the initial ignition and liftoff. That's because we'll be checking the evaporation before we lift off.
Top à 0 moins 1 minute.
1 minute to launch, and we are live at the Ghana Space Center. We are orbiting Thor7 for Telenor and the Space Systems URL, and SICRAL2 for Thor7 and the French and Italian Ministries of Defense built by Thor7 Space. Our very best wishes to everybody involved in today's launch.
Allumage Vulcain. Allumage EAP, décollage. Seconds after launch, we went into Mach 1. Blazing a trail across the sky here at the Ghana Space Center. Tous les paramètres à bord sont nominaux.
After the initial 13-second vertical climb, we rotated to the east and we're heading out over the Atlantic Ocean. We're burning 3 engines, but the boosters... The 2 big boosters are doing all the work right now. They provide 90% of our thrust. Well, if we take my camera, I think I see them flying around with the naked eye. The boosters are burning at 3,000 degrees Celsius. The main stage that we're attached to is at virtually absolute zero, so you can imagine the incredible complexities of the temperatures there. A feat of human tomorrow.
Des étages d'accélération à poudre.
And the boosters are flying away. We've had confirmation now. We can see them, the 2 dots, just through the clouds. Flying back to us, so we don't need the propellant. We don't need them anymore. And we've lost about 3/4 of the mass in just over 2 minutes. So now we're building the main stage. You can see it there, the grey structure, the big tank.
Et nominal.
A huge tank of cryogenic propellant. It's going to burn for about 9 minutes. And you can see at the front there, the fairing on the right-hand side. You can see the image there, the fairing is the nose of the vehicle, protecting our satellites from the rigours of the launch, from the sound and the acoustic waves at launch. It's obviously very, very loud. And of course friction. If you look at the bottom left-hand side of the screen, you can see we're 114 kilometres above the Earth. That means we're on the outer edge of the atmosphere. There's no friction anymore. We're on the edge of space and we don't need the fairing. So it falls back down to Earth and we can see Thor7, our first satellite there. We can see Thor7 at the front for the very first time. The two grey rectangles are the solar panels. Behind it, I can't see it now because it's hidden under the silver, is SICRAL2. We're carrying across the Atlantic using the Vulcan engine. It's very powerful. It burns 320 kilograms of propellant a second. That's about 500 times more than a jet engine. The computer-generated images that we're looking at are showing us what the experts have planned and calculated is happening to the launcher. Okay, so tous les paramètres à bord sont normaux et les parameters on board are normal. We're seeing there the tracking station at Galileo. That's the tracking station at the Ariane Space Center. And the computer-generated images are what's actually happening in space. Basically, the teams plan a very precise schedule of events based on extremely accurate predictions. And they put all of that information into the computer, and these images are a simulation of those predictions. We took off at 5 minutes and 23 seconds ago. Computer-generated images are really showing us pretty well what's happening, exactly what we're expecting to be happening. And there we go, another replay there of our superb launch. The folk in mission control. If you look at the bottom of the screen, you can see our altitude there on the left-hand side. We are 163 kilometers above the Earth. In the middle you can see the distance. That's the distance from the pad if you were to draw a line across the ground. And on the bottom right-hand side is our speed. At the moment we are travelling at 4.29 kilometers per second, ladies and gentlemen. Boys and girls, let me remind you that's per second, not per hour. So we're travelling at 4 knot speeds. And we're heading out across the Atlantic. Il reste 2 minutes de propulsion EPC. He says we've got 2 minutes left of propulsion on the one stage. Our flight path takes us along the equator towards Africa. And we'll start separating the satellites just over the east coast of Africa. Picking up speed all the time here, you can see the trajectory on the
est nominal.
side of the screen. The curve is the predicted trajectory of the vehicle and the dot is the actual position of the launcher.
Les paramètres à bord sont normaux.
And we're tracking our launcher using ground stations as she flies over. It's called telemetry. They've got great big dishes. Like ears, they're listening out for the launcher. And Ariane sends data to those ground stations, which tells us how the flight is progressing in real time. And later we can see how the vehicle performed in a process which is called the level 0 flight evaluation. And you can see there we're picking up the signal there at the next tracking station in Natal on the right, on the northeastern coast there.
Acquisition de la télémesure lanceur par la station Natal au Brésil.
in Brazil. He's just given us the confirmation now that we've picked up the signal, so we've travelled from Gallo. You can see there's a tracking station there on the left, on the west. The Ariane Space Center in the northeastern coast of Brazil. Taking the advantages for launching from the equator, it's the fastest route to geostationary orbit. And also, the natural rotation of the Earth gives us additional speed on the equator. So if you think about it, the launcher is actually already moving in the right direction, even when it's on the pad. Obviously, that's why we're launching to the east, of course.
Propulsion de l'étage principal cryotechnique.
Main stage has cut off its engine, burnt all its propellant.
Séparation EPC.
And it's falling back down. There are images from a previous launch. We had cameras on board a previous launch. Look at that, superb. And you can see the curvature of the Earth and the main stage as it falls back down there. So we are now entering the next phase of the flight. The upper stage has taken the wheel, and its job is to deliver our satellites to their orbit. And the shedding weight, of course, we started with 774 tons, and we've got about 3% of that left. The lighter we are, the faster we go. Might seem obvious to us now, but it wasn't always actually. It was, of course, Sir Isaac Newton who identified that back in the 1680s. That's when he presented his 3 laws of motion. And then about 20 years earlier, he had developed his theories about gravity, and of course that was fell on his head, and he was only 23 years old at the time, so it's quite remarkable. Of course, most of the laws at the heart of that are also at the heart of rocket science. Our first satellite to be separated will be Thor7. There it is at the front. Thor Space Systems manufactured it for Thor using their OS-1300 platform. This is the 47th satellite built by L'Oréal that Ariane Space has launched. There are 15 more in the order book.
SSL is the world's leading provider of commercial satellites with a broad range of capabilities to support satellite operators and innovative space-related missions. Telenor Satellite Broadcaster, a major provider of broadcast and data communication services, owns and operates the Thor satellite fleet, positioned at vertical west, which provides high-powered and high-quality satellite capacity throughout Europe, the Middle East, and Africa. Together, SSL and Telenor have partnered to expand the benefits of the digital world with the multi-gigabit, high-throughput Thor7 satellite. The spacecraft is a multi-mission satellite and features Telenor's first high-performance Ka-band payload for the military market. It is the highest-performing satellite payload designed specifically for service to ships at sea. The satellite also includes a Ku-band payload, which will provide growth capacity for TV broadcast services.
Thor7 is actually a very important satellite for our company. Unlike our previous satellites, Thor5 and Thor6, that were replacement in orbit for older satellites, this is really a brand new satellite for expansion. So in other words, it's going to give us opportunities to grow our business both in the broadcasting area as well as in the data communication area.
The satellite's Ka-band payload has up to 25 simultaneously active spot beams, offering up to 9 gigabits per second throughput for cost-effective solutions and high-power coverage over the North Sea, the Norwegian Sea, the Red Sea, the Baltic Sea, and the Mediterranean. This translates to reliable download speeds in the tens of megabits per second, even to small antennas, and uplink speeds up to 6 megabits per second. The satellite's Ku-band payload has 11 transponders and provides expanded broadcast service to meet the demand for high-definition television in Central and Eastern Europe. At SSL, in Palo Alto, California, a very skilled and experienced team of engineers and technicians worked diligently to make Thor7 an exceptional satellite. This spacecraft is based on the highly reliable SSL 1300 platform and implements innovative and sophisticated technologies to complement Telenor's full fleet of satellites.
Telenor's focus for quality and reliability and certainly as well proven integrity in our business relationship.
SSL would like to thank its customer Telenor for putting its confidence in SSL's technology and leadership in designing and building commercial satellites. For SSL, it was a privilege to furnish Thor7 to Telenor, a company that prides itself on providing the power of digital communications to improve lives and secure a better future for all.
And during that film we picked up the signal at the tracking station in a little tiny island in the middle of the Atlantic called Ascension Island. It's volcanic. It's about 88 kilometers square, and I may be wrong, but I think it's got roughly about 1,000 people on the island.
Wikipedia, the territory includes the remotest populated archipelago on Earth, the Tristan da Cunha archipelago.
And Ascension Island played a very important role during the Apollo era, and right now the teams there are picking up the data from Ariane and sending it to the telemetry team here at the Guiana Space Center.
Above the Earth, we are coming up to 4,500 kilometers from the planet on the ground, and look at that speed. We're really starting to pick up speed now as well. Power before was getting us away from the Earth. We're just starting to climb in
altitude. We need to pick up speed to do that, and you can see there the trajectory on the right hand side. You can see that initial ascent
was very steep, and then we plateaued out a bit, and that will see that we could pick up speed, so that now at this point in the flight we can really start to climb.
We're looking here at the images. You can see if you look at the right hand side, you can see the flame of the engine of the upper stage. The sort of grey and white disc is the upper stage of the vehicle. Then if you travel along to the left, you can see a black structure. That's what we call the
It's protecting the SICRAL2 satellite, which is underneath